Good day everyone. Today we'll be discussing about the two-column proof in triangle congruence. In this lesson, our objective is for you to be able to prove that two triangles are congruent using two-column proof. So in this lesson, you have to familiarize yourselves with the different definitions, theorems, and postulates on triangle congruence. Alright, let's recall. We've learned from the CPCTC, or congruent parts of congruent triangles are congruent, that two triangles are congruent if and only if their corresponding parts are congruent, or which means that when two triangles are congruent, then it is automatic that all of their corresponding sides and angles are also congruent. And we have three triangle congruence postulate. We have the SSS, SAS, and the ASA postulate. Alright, it is also important to know that the triangle congruence postulate enable us to prove that two triangles are congruent comparing only three specially chosen pairs of corresponding parts. So we need only three. That's why we have the, it can be angle, side, 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 or side, angle, side. So we only need three. Okay, so in here, for example, it's the side. So this is corresponding here, the corresponding segment here, and this one. Okay, so we only need three specially chosen pairs of corresponding parts for us to prove that two triangles are congruent. Another important concept that you need to know are the properties of congruence. It is important to know that these properties of congruence are similar to some properties of equality. So it's important to know that properties of equality deals with numbers and properties of congruence deal with figures. The first property of congruence is the reflexive property. So the reflexive property of congruence, this is the same thing with the reflexive property of equality. It's just that in here we deal with figures. For example, segment AB is congruent to segment AB, or angle E is congruent to angle E. Any figure is congruent to itself. The next property of congruence is the symmetric property of congruence. This states that if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Same thing applies in angles. So if angle A is congruent to angle B, then angle B is congruent to angle A. What it is saying is that it doesn't matter which order you say their congruence. The third property of congruence is the transitive property of congruence. In here, it states that if segment AB is congruent to segment DE and segment DE is congruent to segment FG, then segment AB is congruent to segment FG. Same thing applies with the angles. And the fourth property of congruence is the substitution property of congruence. If angle A is congruent to angle B, then angle A can be substituted for angle B in any expression or equation. The same thing applies in angles. If angle A is congruent to angle C, then angle C can replace angle A in any equation, in any expression. Remember these properties because we'll be using them in proving triangle congruence. Let's try it. Let's identify the property of congruence that is being applied. So we have here 1, 2, 3, and number 4. Let's have number 1 first. Alright, we have here angle E is congruent to angle F. Then angle F is congruent to angle E. Which property? That's right. It's the symmetric property of congruence. Okay, but the order. For number 2, segment MN is congruent to segment OP, and segment OP is congruent to segment QR, then segment MN is congruent to segment QR. What is the property? Very good, the transitive property of congruence. How about number 3? Segment AB is congruent to segment AB. Good job, it's the reflexive property of congruence. Okay, it's congruent to itself. Okay, so number 4, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Which property? Very good, the symmetric property of equality. Okay, I think you're ready now to prove triangle congruence. Alright, so when we want to prove something, you want to show some evidence, right? So that is what we will do as well. When we say that two triangles are congruent, we have to show some proofs. So what is a proof? It is a sequence of true facts or statements placed in a logical order. So still, we have to arrange them in order that it will be easy to understand, and it is following some logic. All right, so in a two-column proof, we have these two columns. Of course, we have the statements and the reasons, and in the first part we have the intro. Okay, so first we have to list all the given. Okay, and we have the body. So remember this, okay, every time that you are proving, first you have the intro, the given. Next is the body, the properties and the theorems applied. And lastly, we have the conclusion. And that is where you will see what you are actually proving. Okay, we'll give examples so that you will understand it better. Okay, let's have an example. Given IL, this one, given IL is congruent to LJ and HL is congruent to LK. Also, HLI and JLK are vertical angles. So it's better if you will mark them immediately so that it's easy for you to identify. Okay, so in here we already have here the congruence, ILLJ, then HLLK, and it says also that HLI and JLK are vertical angles. Okay, so we have all those. Now we are to prove that triangle HLI is congruent to triangle KLJ. So where's that? Prove that triangle. Let's change its color. Let's make it red. So prove that triangle HLI, so this triangle, prove that it is congruent to triangle KLJ. Okay, so let's use the two-column proof. So we have on the first column we have the statements, and on the second column we have the reasons. And we know that for the first statements we have the given, right? So our first given is that IL is congruent to LJ. What is our reasons for that? That is already given. And angle HLI and angle JLK are vertical angles. What's the reason for that? Yes, that's right. That is also given. For our third statement, we have angle HLI is congruent to angle JLK. What is our reason for that? Very good. The vertical angles are congruent. Okay, for our statement number 4, segment HL is congruent to segment LK. What is our reason for that? That is also given. And so, for our number 5, triangle HLI is congruent to triangle KLJ. This is the one that we are proving already. Okay, so we have enough evidences and proofs. So can we conclude that triangle HLI is congruent to triangle KLJ? Yes, given all those reasons. So by what property can we conclude that triangle HLI is congruent to triangle KLJ? That's right. Side angle side postulate. So in here we have the side angle side. Okay? Let's have another example. Let us look at our illustration. So we have here the given, and we have to prove that segment AB is congruent to segment CB. Now let's put the markings first. So angle CDB is congruent to angle ADB. Okay, this one. And angle ABD is congruent to angle CBD. Okay. Prove that segment AB is congruent to segment CB. Okay. Let's have our two-column proof. Can you give one given? Okay. Angle CDB is congruent to angle ADB, and it's given. Next, segment DB is congruent to segment DB. This one. And what is our reason for that? Yes, that's right. Reflexive property of congruence. Okay. What statement can you add? Yes, angle ABD is congruent to angle CBD. And that is given. Okay, let us look at this. We can say also that triangle triangle ABD is congruent to triangle CBD. And what is our reason for that? Let's look at the illustration. That's right. We have angle, side, angle postulate. And so, can we prove that segment AB is congruent to segment CB? Yes, and what is our reason for that? The CPC-TC. Okay, because we know already that by ASA postulate that they are congruent. And we know that corresponding parts of corresponding triangles are congruent. Okay? Okay, let's have another example. Let's look at our illustration here and look at our given. So what are our given? We have segment EF is congruent to segment HF. Okay, let's put the mark so that we can easily see it. And G is the midpoint of H. Alright, so this one. Now we have to prove that triangle EFG is congruent to triangle HFG. Let's use our two-column proof. And let's write the given first under the statements. What are the given? Very good. First, segment EF is congruent to segment HF. And what is our reason for that? Yes, that's right. It's given. What is the next given? Yep. G is the midpoint of EH. Okay, or segment EH. That is given. Okay, this time you have to think of your knowledge on definition, theorems, and postulates. So we have EG is congruent to segment GH. So EG is congruent to segment GH. And what is our reason for that? That's correct. Definition of midpoint. So midpoint bisects a line segment into two equal parts. Okay? Or two congruent parts. Very good. Next, segment FG. This one, look at our illustration. We could say that segment FG is congruent to segment FG. And what is our reason for that? Very good, reflexive property of congruence. And so by looking at all our statements and reasons, we can prove that triangle EFG is congruent to triangle HFG. Look at our illustration. We have the side, side, and side. So our reason is by SSS postulate. Alright? So that's how we've proven that triangle EFG is congruent to triangle HFG. Now let's try answering. Let's apply from your module. Okay, so based on the given figure, complete each proof by writing down the corresponding statements and reasons. So we have here our illustration, and the given, we are to prove the triangle RMZ is congruent to triangle GMN. So we have here statements and reasons, and we have to complete, okay, or to fill in the blanks. So for number one, angle Z and angle N are right angles. What is our reason for that? Yes, that is given. Very good. How about number two? Angle Z is congruent to angle N. And it's if two angles are right angles, then they are congruent. That is for our reason. And for number three, given. That's right. So given angle line segment ZM is congruent to line segment NM. Here, that's given. And for number four, the reason is if two angles are vertical, then they are congruent. So what's our answer? That's right. Angle ZMR is congruent to angle GMN. So this is congruent to this, and this one is also congruent to this. So look at our illustration. We have here angle, side angle. Okay, so can we prove that triangle RMZ is congruent to triangle GMN? Yes, by angle, side angle postulate. Okay. Alright, now it's your turn to answer the number 2. Let's answer together the first part of let's analyze. We have our illustration on the right and we have the given. Okay, so again, fill in the missing information for our statements and reasons. So for number 1, segment AB is congruent to segment CB. So here and here. And that's correct, it's given. So what is another given? D is the midpoint of AC. That is for our number 2. And for number 3, the reason is the midpoint of a segment divides a segment into 2 congruent parts. So what are the 2 segments? So yes, that's correct. We have AD, segment AD is congruent to segment CD, right? Because the midpoint, which is the D, divides the line segment AD into 2 congruent parts, right? So let's go to number 4. What else? Okay, look at our illustration. We can say that BD is congruent to BD. Okay, so BD is congruent to BD. What property is that? That's correct. The reflexive property of congruence is equal to itself. So by looking at our illustration, we could say that the side and side, they are all congruent. So triangle ADB is congruent to triangle CDB. And what is our reason for that? It's by side postulate. Did you get that correctly? Good job. Now it's your turn to answer the number 2 of let's analyze. Answer as well the assessment part of your module. I hope you've learned a lot. Thank you for listening. Until next time, this is Teacher Marcel Buerano.